Okay, so we're going back to 1981. One of the first legal sets on the market was the JWR M2. Never did see an M1, never did see an M3, though I did see mock-ups of them. But this was the one. And these transmit very nicely. They sound better than the receive is. I see these as one of these bleed over box type sets, but I might be wrong. We're going to be doing selectivity tests in the not too distant future. We've got the equipment in. 12 volts only, do not plug into mains. That's handy. And you get some saucy looking young lady saucily talking into her CB radio. It's nice to get the gift box with it. This was an eBay purchase a few years ago, probably about 4 years ago, and it's sat on the shelf ever since. And prices have kind of shot up since there. It's come with a destruction book, which is useful. I've genuinely not opened this. Now I seem to remember these are one of those sets that you have to set the you have to set the 10.24, then you have to set the transmit, and then you have to set the receive frequencies all separately with a Marker Oscillator. When CBs became worthless about 1985, these were the kind of sets that you could pick up for a few quid, and they were easily alterable to go onto handband, if I remember. So a lot of them, the ones you see, are ruined because they are failed projects. Tell you what, that is nice. It even smells new. So put that on one side. Oh, mark. I can almost see a mug in this. It's 38 years old. So were John Wolfe Racing some kind of Pimp My Ride kind of organisation? I'm not sure. I don't think they were racing horses, were they? Really? Are they still around? Why did they get out of CB, or were they just greedy and got into it to make a few quid? Self-tapping screws, which I do not like in CB radios. Were these Hong Kong? I'll just check the back again. Oh no, Korea. I've put the soldering iron on because I do remember you have to unsolder the speaker. As I say, if I remember rightly, you've got 3 crystals. Yes, you've got the reference crystal, which will be the 10.24. You have a universal synthesizer chip from Motorola, MC145106. And then you have transmit and receive mixer crystals as a separate entity. So it's nice to see. Oh, what's the extra preset for then? Looks factory, whatever it is. I wish you could smell this. It smells of new CB. And do current new ones still smell the same? I don't know. I can't remember. I think we'll work on it on its lid in case there's a capacitive effect. Be alright saying if I had a stutter. So the power plug for this is a rewirable one, so you can unscrew it and put new wires in. How good's that? I don't think these were that expensive. I seem to think they were always round about the $49.99 type of price. So we have a full power lead. Connect that up to our handy crocodile clips. Now yesterday I was working on that Midland emergency set, so I'm set up at 12 volts. I need to just make sure I'm on 13.8 for a mobile set, which I now am. Do not transmit until antenna is connected. This will damage the set, which it will. Take off the adapter from yesterday's set. We're going to do the field test on that today. So Mr Chippie will be taking it out in the car with the antenna supplied with it. So to be honest, this looks untouched. But we will just see what it's doing on transmit right now together. Let's put picture in picture and it's on. So I press transmit. Oh, we're on channel 20, it's on 19. So at the moment it's doing 450 milliwatts, so I wonder if it's on low power. It is. It's doing 3.4 watts. And just so we can both see together, see how the frequency is doing. To be honest, that's spot on, 277912. I'm going to have to go through it though, because at 38 years old, it could be off on receive, or the 10.24 could be off. So this is the thing, this is the difficulty. You have to set that, set transmit, set receive, and without a marker oscillator, you're stuck. I think we've got a new Chinese signal generator to use a marker oscillator. We might play with that. So you get a circuit diagram and a block diagram. I'll be able to scan this and I'll have a first generation scan. So most of my scans are from first generation photocopies. Yes, that's quite nice. Do not swear on channel. I remember a court case in Sheffield. Oh, got a specification there. And one microvolt for 10 dB. That's awful. I'm going to have to test that, aren't I, now? Yeah, this gentleman in the court case, he got taken to court for swearing on the CB. I'm going back to 1981, 80, well, it'll be 82. And when he went into court, he said to the judge, I don't know why the bloody hell I'm here. So, I think the judge dismissed the case, saying, well, he's actually talks like that. Okay, let's see if we can hear something. Do we have to connect a negative to this as well? How inconvenient. Oh no, we can plug in. What am I doing? We can plug into the extension speaker socket on this one. Don't know what I was thinking of there. So we'll put 2779125 in. I think we're there. So let's get 12 dB. There we are. Might be able to change scales. You know what? It's doing 1 microvolt for 12 dB synad. And what did it say it's supposed to do? It's supposed to do... Oh, it's better than it's supposed to be. It's supposed to be there. it's actually doing 0.7 for 10 decibel. So by today's standards, that sounds deaf, but we haven't been through the receiver yet. I'm sure we can improve it. I've said it loads of times, when they align these, they don't go backwards and forwards like I can do. They are aligned once, and when it hits that minimum accept, the radio goes out. They're probably given 40 seconds to align them in. Pity there's not a layout for this. So looking at the transmitter, what have we got? So transmit probably starts at 301. So which is coil 301. So coil 301, don't know why I didn't screw that in properly, is that one there. So we'll just start by seeing if we can align the transmitter, and then we'll start worrying about setting up the frequencies. So that looks to be the first coil we're going to touch. So that's now about 3.7. Just have to melt that a bit more. It's 4 point something. Basically, we're going to detune it because it's now gone above 4 watts, about 4.2. We'll detune it with the final coil, and with the spectrum analyzer, we'll see whether we need to detune it upwards or downwards for the least possible second harmonic. So we'll go over to the spectrum analyzer. Press auto, we'll see whether we can pick that up. No. Okay, frequency 27,79125 megs. So there we have that. Let's have a little look up the road. You know what? I can't see anything. So that's 27-ish. That's 53-ish. could be a little tiny something there. It's spot on. So I'll detune it to 4 watts. In fact, it's nearly there now as it's warmed up. And we've still got no spurious. We'll go back to the 28. Yeah. Oh, that'll do nicely. It's cleaner than most sets. That's that done. Now, I know I've covered these sets before, but we'll start afresh. And what we need to do is to just set that 10.24 crystal. So I'll just look at the circuit diagram and see which pins we need to monitor to do that. So the crystal is between pin 4 and pin 3. Pin 4 and pin 3. So what we need to do is to connect the frequency counter to those pins. So we'll go to the right camera, which is 2. I'd be set up better, you know, if I did these all day, I would be set up with probes and that which actually fit instead of bits of crocodile clip. So 1, 2, 3, 4. Did I say 4? Yeah, 3 and 4. So we've got 10.2372. See whether we can bring that up. So I'm on pin 4 and earth. Now we're not bringing it any higher than that, it seems. Now, where are we on transmit? You know what I think somebody's done? I think they've set the frequency with the 10.24 like you would do on a normal set. So I don't remember which oscillator it is. Obviously it's one or the other. Let's go for that one. I'm right. So 2779125 we're looking for. I know why they've done it, because it won't quite go. So I've got that as low as we can. see whether we can trim it with the transmit one once again. Okay, so we're where we want to be, but you shouldn't be adjusting that to get the frequency. But I suppose the crystals are now all out of spec. So what it can mean is that the IF, the intermediate frequency, can now be lopsided. In reality, I don't think it's going to make any difference. It's not like it's the radio for a spacecraft, is it? So what we're going to do, we now need to inject a 10.695 signal to set the receive, and we're going to use, I bought a cheap Chinese signal generator, and this is going to be the unboxing ceremony of that. Let's see what they've sent me. A Field Tech. How handy. It even comes with a UK mains adapter. Because normally we use the Marker Oscillator, and our Marker Oscillator does 455 or other normal business radio frequencies for IFs like 10.7 and 21.4. Because CBs are 10.695, we can't use it on 10.7, so we can use it on 455, but it's harder to do. Same result, but harder to do. So let's see what happens here. Good grief, how can I see that? Let's put the box out of the way up there. What we want to do is to set this for 10.695. Wonder how you do that. So frequency, this up to our frequency counter. I think this was about 40 quid. It wasn't huge money. It was cheaper than buying a crystal custom made for 10.695 and building an oscillator. So channel 1 output. Most of these will only go up to 10 megs, and this one goes up to 20 megs, and with us wanting 10.695 we wanted the more expensive model. Let's see whether we've got enough output to just crocodile clip it together. And you know what? It stopped receiving, hasn't it? As this signal from this has blocked it. So we're reading 10.694978. So between that instrument being slightly out and this being slightly out, yeah, I mean we're spot on, aren't we? That's fantastic. Well, I'll tell you what we can do. We can, because this has got all these extra digits, we can trim this. .69. No, it's not that digit that wants to move. It's that digit. There we go. 10.694999. We're not going to get more accurate than that. So I've compensated for the slight discrepancy, and I'll turn the tone off the signal generator. I'll move the leads away somewhat. We could do with attenuating this, if it will. Is that? I wonder if that's the amplitude. No. Is that the amplitude up there? Attenuate, that's it. Oh no. That's actually where we want it. With 20 decibels of attenuation. It's difficult to hear this. There we go. Can you hear that musical note? I'll turn the volume up. We need to null that when I get the tool in. Hear that? Off frequency, on frequency. So we know the signal generator. Let's go back to the signal generator. He's doing 27,79126. We know, because we've got the counter on it, that the Marker Oscillator is doing 10.695. So the only thing which could possibly be out is the crystal, and that's how we've done it. So we've had to do a bit of jiggery pokery to get it on frequency. We should be able to set 10.24 there, bring it onto transmit frequency with that crystal, and then do this setting on frequency with the Marker Oscillator with the third crystal. So it's gone, but it isn't ideal because I know that the receive is going to be lopsided. It won't matter in practice. So there we are. That's our new Field Tech toy, and we bought it solely to do 10.695 Marker Oscillator things. When we get some of those crystal controlled handhelds, we need this kind of thing. So that improves what we can do here. So that was today's little extra thingy. So I'll put that away. How do we turn it off? Oh, there's a switch on it. I wonder if it remembers what you've put in. No, of course it doesn't. Right, well, I'm pleased about that. That was easy. So we've done that part of transmit. I'll look through the circuit and I'll just, instead of fiddling with all the different presets to a hit on the right one, I'll just work that out from the circuit and write it down. So I'll go and have some lunch and I'll be back. Put the tone back on the signal generator. Okay, so getting back onto this, I made some notes as to what should do what. So we'll get on with finishing off the transmit. So TX meter should be RV302. So let's see if we can see RV302. That one on the end there. 301's the receive meter, so the 2 meter ones are together. So we'll go into transmit. And let's look at that meter. Centre of the red zone. Done. Transmitted audio. TX audio, we've got 303. So it looks to be that one just there. So we'll give it the quick whistle test. While it looks spot on, but we'll just look at it with the oscillator. While yeah, that's it. So that's that done. So move over to receive now. And let's look at the oscilloscope. So with an S9 on the screen, on the signal generator, see that is lopsided. When I say with that being off frequency, the receive could well be lopsided. That was 10.237 something or other, which would mean the IF becomes 10.692 or something like that. It's not stupidly out. So I've got 104 for the detector, which is the one with the wax in it. Just wait for the soldering iron to heat up. You know what, while we do that, I think we can set S9 on the S meter. So we've got the 100 microvolt signal on there, it's 101. Yeah, that's a bit wild. Wow, that's a fine thing to set. Now that's not affecting in the normal way. I've just reset that with the cyanide meter, so I might be wrong. Let's see if it's that one. It is. So we can have it to the left, we can have it, I think we're about there to be honest. So the detector was 105 that I didn't even spot on the circuit. So now we'll look at the front end. So we'll go over to the cyanide meter. Drop the signal till we've got about 4 decibels. That was already spot on. That was already spot on. Let's have a look at that IF1 there. T101, T102, T103 and 4. We're not adjusting any of the VCO ones. So we'll just make sure we've still got S9. We're spot on S9. So we'll get a reading for the cyanide now. So where are we? We may as well start where we are. So we're looking at 0.72 microvolts for 12 decibels. And we're looking at 0.58 microvolts for 10 decibels. We'll see if it does 20. You know what, it's not wanting to do 20. We may be able to adjust something to help. Let's go back to that one. Yeah. And we'll now see whether that's affected the detector. Right, now we'll try again. So just check we're still there with 12 decibels, or whether it's changed. 0.74. Naught 0.58. Yeah, that's the same. 20 decibels. We're just between ranges. We're often just between ranges. It's, well, to be honest, it's about 4.2 microvolts. So it's got noisy transistors. Not because it's gone like that, because it was always like that. So what's it supposed to do? I'll just turn the volume down. Right, so it's supposed to do 1 microvolt for 10 decibels. Well, we've got 0.74. So if we go back to the synod meter and we put in 1 microvolt, that's 1 microvolt. So if you look at that, we're looking at 14 dB for 10 for 1 microvolt, and as I said, for 10 dB we're getting 0.58. So although this to me isn't that sensitive, it by far exceeds the specification. We're shortly going to be setting up some equipment, and I'll tell you what, we might start with this set because it's well known for bleed over, for the rejection, the selectivity, more than 80 decibels it says. That's what we're going to be testing for. I bought a second signal generator used on bench 4A. This is bench 3. I'm glad it says 10.695. I didn't look at that. It's because CBs are in this country. So that should just leave us. I'm glad it exceeds specification. It's doing the full 4 watts. It's doing the deviation. So I can't remember whether these were notorious for squelch or not. I just can't remember. So, is that the squelch preset there? Because I can't see anything else. Oh, unless that's low power. Let's have a look at low power. So we already know it was doing 0.45. Let's see whether that adjusts low power. Yeah, it does. That's it, 0.4. So that's done that. So I don't think squelch is adjustable, and this was one of the little niggles on these sets. That's probably what that preset is underneath. Right, so I've turned the squelch to full. Let's see where it comes in. 100 microvolts, just where it should be. But just out of interest, is it that preset underneath? Yep. It is. I think that's the best compromise we're going to get. So it looks like some of these have got a squelch underneath. I can't say I've seen that before, but then I've got a memory like a sieve. So we'll set the squelch now to, we'll switch it off. I'll put the camera on that set of controls for the attenuator. So we've got it parked at 0.3 of a microvolt, that's at 0.3, that's at 0, and the signal generator is off. So what we're going to do is set the squelch. That's threshold. It's a bit noisy, that control. Is it the type we can spray? It is. It's probably bleed over from 24 miles away. So we'll switch the signal generator back on. We've actually got a dry joint somewhere. Right, that test again. Squelch to threshold. Signal generator back on. So it's coming in at 0.5, leaving it 0.4, back at 0.5. So the sensitivity is where we want it to be. Do that once again. Right, I'll just go looking for the dry joint. Straight away I can see two areas of problems. We can zoom in on that. Don't need that anymore. Let's get rid of it. So first of all, we've got corrosion around those three pins. So that's the MC3357 and the squelch is within that chip. Also, we've got some corrosion around that area. So whether or not the board wasn't defluxed properly or whatever, we'll turn it off. Now, where have we hidden the Kleenex there? So I'll have to come back to this because it's going to have time to dry. But any corrosion like that, whatever it is, spider poo, whatever, needs to be gone. And these boards are defluxed, which is, you know, not that many CBs are. So I'm going to leave that half an hour and then I'll come back and we'll finish the video off. Okay, so now we've got it back on an aerial. We've got it on an aerial. Let's see move that camera out. God, it's like Americana, isn't it, this? Straight out of Dukes of Hazzard. Is
it raining or is it snowing?
Oh well. Go on, Nana, Roger.
We've got the garage.
19 and Roger.
Skating on side of it. As long as I whip the shop.
19 and Roger. Okay, it's all gone quiet again. So we'll do an on-air test tonight with that, and there you go. This came in other versions. If any of you've seen the Murphy DS602, it's very similar, but uses a more normal synthesizer chip, the LC7137, instead of this general-purpose synthesizer chip. And then there was the version, the ICOM ICB 1050. Don't think for a minute it's anything whatsoever to do with communications company called ICOM. It is absolutely not. So it's just a use of a name in a pirate fashion. So no, but that's another version of this chassis. Also, I think the Signal 1001, if you've seen that, and the Lucas ACB 888. Right, thank you for watching.